introduce the hardware. Human depth counter. So you can record the how much you down pass or uplift. Yeah. So you can know in which depths there's defect or something else. Yeah. And this is the for this probe or transducer to transmit ultrasonic wave and also receive the ultrasonic wave. Now we connect, and usually we can number the pipe. We always number the nose as the first. So this one, the first and clockwise, first, second, and third, like this. And here we have for this equipment we have 4 channels. Every channel can transmit, and every channel can receive 4 channels. And also this probe, every probe can transmit and receive. So you can insert any channel. There's no difference. And H is for the depth counter. And here we only use 3 channels, for example. And operation, there's no difference of the operation. Okay, first, also setting, project name, and what we test: diagram, wall, square, or circle, and then panel number. Also seal pass, and panel length. Panel length is the design length, and we have a test depth because here this cable have a scale here, and after we insert into the pipe, so we can read the number on the top of the pipe, right? Okay. But in fact the pipe is higher than the top of the pile. So the scale we read is higher. So we need first read this scale, and we reduce the depth outside of the pile top. Yeah. So that is the real test depth. And another one is sometimes maybe the pipe is blocked by some soil, by mud or something else, by rock. So maybe the test depth is not the pile length. So we need to read the scale and get the real test depth. And then the pile diameter, only for record. And this is the node spacing. Node spacing is like this is we lift the probe. So if I said 100, I lift 100 if we will record data, and 100 data like this. So if I said 100, so 1 meter, I will test 10 times. So if I said 10, that means 1 meter, I will test 100 times. Most of the time, 100 is okay. And depth record format is auto read, and some equipment like this is equipped with wireless depth counter. But this one is wired. And here we can set the pipe number 3 or 4. And angle is the, let's see, angle to north. So you can choose to input the, you can also rotate. So next time or after you analyze it, you can you know which one is the pipe 1, which one is pipe 2. standard, ignore that. And then the span is the distance between two pipes. For example, these are two pipes. What we need to measure is this side to this side, not outside, not the outside, this inner side, this. And we measure every span of two pipes. For three pipes pile, we test three span, and 4 pipes we test six. And here channel we just choose self-send and receive. Self-send and receive means every probe can transmit and receive. And if I choose one send and multi-receive, will be like this. Only one transmit and other two only receive. Yeah, so we choose this one. So in a test, what we need to set is the length, test the depth, and the node spacing. If there is no special requirement, we can just fix like 100. It's okay. Normally 100 is okay, and test the span of different pipes. This is a normal setting, and we have an advanced parameter setting. Okay, first check this sample interval. Oh, interval comes again. So now, do you know what interval means?
Yeah.
So we have width. There are many points. The distance between 2 points is the interval. Yeah. So, but here sample length we can set. We can set to 512 and 1024. But this sometimes we need to manually input only for some very large span, like 3 meters, 3 meters or 4 meters like this. Most of the time we don't need to change here. It's already enough, very enough. And post-wise is the signal of the system of the equipment inside transmit to receive time. So we don't need really to understand what it means. Just when we set low voltage, we set 3, and when we set high voltage, we set 1. It's okay. In 99%, we don't need to change. And pulley is the depth counter. We have 3: big, middle, and small. This one is small, and middle is wireless, and with the bigger one is like this. Here we choose small, and so we can see we can set small. There will be pulley diameter already inside, and this is the cable A, cable B. This is cable A. Okay, then next, pipe and the water adjust. So why we have this? Because the principle of cross-sonic logging is one probe transmit and one probe receive, and the ultrasonic wave transmit in the concrete. Right. So the span is also the span we said we want it to be the distance between 2 probes. That means that we want to know the thickness of the concrete, and we test the time from the equipment, so we know the velocity of this concrete. Right. The CSL, the final result we get. One is the velocity, the wave velocity. Another one is the energy. So during the transmitting and receiving process in the concrete, if there is any like defect, empty something else, the velocity and the energy will change, right? So according to the velocity change and the energy change, so we can know if there's anything abnormal there in that depth. We really want is the thickness of the concrete, but in fact, you can see the probe, the signal. Okay, first from the equipment, and then the cable. This cable is only 30 meters, but in fact, we equipped with 100 meters cable. So it's very long cable, and the signal need time, right? And then come to the probe. Probe we put in the pipe. It's water in pipe, right? Yeah. And outside of the water is the pipe, yeah. And then is the concrete. So we have the time in the cable, in the probe, in the water, and in the pipe. Yeah. So we need to cut the time in the cable, in the probe, in the water, and in the pipe. We put the diameter of the pipe, diameter of the probe, and the velocity of the pipe, and the velocity of the water. So we can reduce the time in the pipe, in the water, and in the probe. But there's still one that we don't know, is the time in the cable and the time transmit and receive. So how do we do that? We cross to probe. Okay, now there's no media in the of two probes, so there's nothing else. And also we need to make this correct time to 0. How to do that? We just make this 3 diameter the same. This correct time will be 0. You can set to 0 is okay. Okay, we set all of the time to 0, and we come back. We click sample. We cross these two probes. So there's nothing between two probes. The time from the transmit cable, probe, and the receive is here. Another one, the yellow one, yeah. Then you can see this is the first arrival time. That means and you can see we mark first arrival time. The T is 10 ms. That means totally from transmit to probe and to receive, we need 10 ms. And we can check another one. This is 1 to 2. Now we can check 1 to 3 is blue to yellow.
Okay.
That's the first arrival time. Then this is the like a delay time of the signal, and we input the time here, like 1 to 2, 1 to 3, like everyone. Normally the time is between 7 to 13. If you don't want to test every time, just 10 is okay. Yeah. So the error will be very, very, very little. And don't forget, come back to this one. Pipe outside diameter, inside diameter, and a probe outside diameter. But this one we need to measure ourselves. can start and input the information here. So the pipe is very sharp, and the pipe should be filled with clean water.
Second.
Ten meter, 8 meter. We test the flow. Okay, balance is it's about 10 meters. Check the scale. We use 10-20. That means every scale should be 10-20. Yeah, this should be the same position. And then we test the depth. It's 17. So it's panel. Then we tested the span of different height. Yeah, first 1 to 2 is blue to orange.
57. The blue to orange. Yellow is 56. 56.
So we input the balance, and then we get the test depth, and we measure the span of 3 pipes.
Yeah.
So here we don't need to set anymore. Okay, then we save and okay. Now we can sample. You can see the wave very weak, so we can adjust. We have 2 adjust parameters. One is gain, one is delay. Gain is like a magnified wave. We can, for example, we can set to like 40 and 40.
Okay.
This one not good. This is one not bad. This one is good. You can think that the span are almost the same, right? So same gain. This should be almost the same. So maybe yesterday I tell you that in the bottom of the pile there always and there's another one delay. Delay is just we delay some time, then we start sample, right? We make the wave go right. And here in CSL, we prefer to make the first wave at about a half to a quarter. Yeah, like this position. So we can adjust the delay. Like second one is good, third one is good, but first one, let's set. Okay, like this. And this is manually adjust. And we have a function called auto. Yeah, so click auto. Sometimes it's good, it works well, but sometimes maybe not well.
Okay.
Yeah, so we can, after we click auto, we need to click fix because the parameters cannot change during the test.
Yeah.
Okay.
Other the one.
Yeah. So if you think this is not very good, because I just said the first arrival time should be about here. We have a quick adjustment button here. This is like a delay minus. You can move the and or magnify or minify like this.
Okay.
Also this one. Okay, this is good.
Okay.
And now you can go back the probe. And then they arrive the. Let's check if the go back to the bottom. If you want to start the test, we need click new. Yeah, we must click new. In sample here, in sample interface, it will not collect data. New. Okay, test. Okay, and lift.
We need this direction. Because in this direction, maybe go up,
Get down.
down, like this. This is normal operation.
And don't be too fast, but this one's okay. You can see here's the icon. If this is green, that means the speed is okay. If too fast, it will become red.
Do you see something different from the result?
Okay, let's take a look of the test. So yeah, so it's very obvious,
Yeah.
right? Here and here.
Yes, just the look abnormal area.
And also a little on the bell bottom, right?
Yeah.
Because the seam gain and delay is normal in the bell body in the middle, but abnormal at the bell
The
bottom.
weight will be high.